Good morning, my name is Stuart, and today we're going to talk about synthetic transactions as an aid to monitor in both depth and breadth. So, a lot of monitoring systems are excellent in that they have either inspection by looking at the surfaces of systems, for example, a liveliness test of an API, a database, a queue, and so on. But it doesn't always tell us if the system is healthy and, more importantly, useful. So just because the surfaces tell us that the system is responsive doesn't mean that the system is fulfilling its business purpose. So introspection tools like App Dynamics and others that do deep stack tracing can be a significant improvement. Some of them offer facilities that approach synthetic transactions, but they're typically very technically focused, and they can also be spendy if you have a very big infrastructure, but that can be worth it in some cases. And the thing is that tooling like that covers DevOps, right? It covers the area that developers and operators care about, but it doesn't really address the business side, which is that users have goals. And what we really want to measure if we're doing a good monitoring program is whether or not users are meeting their goals, which lead to the definition of what a synthetic transaction is, right? It's user goal monitoring. Did users get to their goals? So if you sweep aside all the technical implementation details, which are pretty well documented, and focus on the business purpose and sort of the high-level architecture and design of synthetic transactions, we can have a pretty useful conversation. So what's the goal in this case? It's to emulate the end-to-end flows that represent users getting to goals. So here's some use cases, right? Here's an e-commerce use case. Here's a use case where a user's trying to get driving directions, claim processing, logistics, right? These are all clear use cases that you would define as part of a business statement. And they all have one thing in common. They have a primary actor, a system, or a user. Even automated systems can be said to have a user surrogate in the form of a machine actor. These days, we don't really differentiate between those two things. As long as we have a person or a thing that's trying to get to a goal through a series of steps, then we have, and we want to watch that, then that's what a synthetic transaction is all about. So what's interesting about synthetic transactions is they're often a lot more diagnostic when they fail, but they're still useful in telling us things we want to know. And we're going to see that in a minute. But I wanted to start by saying where we can get synthetic transactions from. So if you have end-to-end tests for your system or integration tests, or you have a series of tests that you could string together that would represent a user journey, then that is a good source of synthetic transactions. And if you have business use case testing where people are manually testing to see what the user experience feels like, if you were to automate that, that would be an excellent synthetic transaction. So we want to choose very selectively for a couple of reasons. First, we want to make sure they're meaningful. So we want to see synthetic transactions yield core business value. In other words, we want to be measuring the parts of the journey that are of the most important from business value, right? What is impactful, what has revenue, and so on. And the other area we want to make sure that a synthetic transaction reveals is risk. So we want to make sure that we exercise the journeys that will give the highest exposure to the business of a negative consequence, right? The potential for loss. So I want to talk a little about business process nomenclature. And we're going to simplify it considerably. There's actually a whole language or set of languages around describing business processes. If you're interested in that sort of thing, there are plenty of good references on it. I'm going to simplify hugely the nomenclature that helps us sort of anchor what we're talking about. And that is, we're going to talk about an on-ramp as being a place where the journey starts and an off-ramp as a place where the journey ends. And the thing that happens in the middle is the business process. And here we have an on-ramp with an entry point and a process, and that leads to a route or a decision. And we either follow flow A or flow B. And if we're successful, we hit an exit point, and then we have an on-ramp, an off-ramp. And so this is just, the green boxes in the middle can be as simple or as complicated as they are. But it's important that we anchor the ends of the journey so we know when we're starting and stopping our measurement. I'll point out that the reason that many organizations are reluctant to do synthetic transactions in production, which is the only place they really have a lot of value, is because the result of a journey can result in something happening in the physical or financial world. But, for example, if I'm an e-commerce company, I could actually end up ordering something and shipping it. If I am a financial services company, I could end up with a trade, or some other financial consequence. And if I am in the business of providing goods and services, I could end up with an order that's not real. But I'll point out to you that those are, in fact, real. That objection is a spurious one. In fact, the justification is exactly the opposite of the justification they give. If we look at the big businesses that are hyper successful, we look at Amazon, they issue synthetic transactions that exercise all part of their order and fulfillment process all the time because they constantly want to measure in the real world how things are happening. And I'll point out that you can use actual transactions as synthetic transactions. In other words, if you have instrumented your system correctly, that you need not necessarily generate custom loads, custom orders, custom whatevers, but that the regular transactions you feed through their system are diagnostic as well. But synthetic transactions are extremely useful because they represent a set of consistent use cases that can be used to baseline. And so if we think about Netflix, in addition to monitoring the stream starts that they do, they also effectively exercise their system by, over a wide geography on different providers, on different device types, actually doing the thing that Netflix does, which is asking for a stream and consuming it. And so they measure not only the ones that their actual customers use, but they also have a set of baselines they run. Amazon uses its synthetic transactions to make sure that all parts of their process, including the mechanical process of picking a product and packaging it and shipping it, is what they expect, right? Then that allows them to measure how their warehouse folks are doing and how their the folks who are then getting those packages onto carriers and how carrier performance happens and whether or not items are packed adequately, right? They actually physically have somebody open the box, they deliver it to a real place, they have somebody open the box and score it, and then that's their off ramp, right? So the business process doesn't have to just be the digital part of the journey. And successful companies that mix bits and atoms always include in their synthetic transaction process those parts that are in the physical world. And if we're doing, for example, stock trades or whatever, they can trade one share of stock without it, or 2 or 10, without it really affecting anything, because they're going to exercise buying it and then they're going to exercise selling it. And the difference in profit and loss is so trivial, it's not even budget lint, but whatever the price there is, and occasionally it actually sort of makes money instead of costs money, whatever that cost is trivial compared to the cost of not understanding or not instrumenting their business process from end to end and having something that would cause a loss of face, a loss of business, a loss of reputation. And synthetic transactions are not instantaneous necessarily, right? They represent a long-running, or what I call saga processing. And what's more important is that the trend of the same transaction done at different times of the day and different days of the week over a long period of time, those trend lines are really interesting to the business and to the technologists, because they speak to things like scaling and bottlenecks and process problems. And if you then overlay that onto a map of releases, and each release is earmarked to a series of feature additions or process improvements, then you have an empirical way of judging the impact of those releases. So here's a couple of requirements. We need a unique identifier of some kind that is going to follow us all the way from end to end. So on the digital side of the equation, and we can use something like a Zipkin or Dapper or Jaeger token. And where do those come from? They usually come from the web application firewall or the load balancer closest to the world, right? And we can add those things, and those are added to the header in our flow. We can generate GUIDs or other UUIDs and use those and inject those into the flow. And what's really important is that those identifiers flow from end to end in our system, right? And when we transition to the physical world, what we do is we encode those identifiers in such a way that they can be rapidly scanned. So turning them into a barcode or turning them into a zebra code are ways that we can then scan that and correlate our physical activity with the digital identity, so that when the box shows up wherever it is and they bring up the screen that they type in the stuff, they start by barcode reading the box, and then we look up some data and we get our transaction identifier or identifiers. If our process forks and branches, we may have a base transaction and then a bunch of sub-transactions underneath that. That's perfectly fine. We may have surrogates for the transaction. So, for example, we may have an order number, and that order number may be one to many to a whole bunch of transactions, right? So by modeling the data space, we're able to build correlators and hence correlation between the digital and the physical world and at every step in the digital world. And we want those things to be present in the digital world and all of our logging, and we want them to be part of our state bucket. So, stored in the database, or in metadata or somewhere, right? We need to be able to get at them so that we can pull that data together and relate it in a meaningful way. So if we create records in the database as the result of this transaction, we want to tag those. If we create physical things in the world, we want to tag them with that. And this is not new, right? Companies that produce physical things in the material world, pharmaceuticals, guns, industrial products, things that have unique serial numbers, and they have the composition of many, many small parts. And for various reasons, compliance or otherwise, they want to track all of the things that flowed into that physical thing that was then delivered to, as part of a journey. So this is not new. We're just saying that work that's done to make sure that we know, for example, for a batch of aspirins that we tag that and keep track of throughout its entire cycle. So if there's a problem, a quality problem, or a supply chain problem, or a tampering problem, right, that we can go look in those records and find out what's going on. And we should have that level of granularity for any serious enterprise systems that we ship. So we want to have that metadata emitted as logs throughout every step. And again, in the DevOps process, logging is sort of table stakes. But this idea that we're not just going to log kind of arbitrary things in arbitrary ways, that we're going to do it with discipline, is very important. So we want our trace identifiers, we want our message identifiers, we want message types. And in the area of the digital realm, that's using sort of the industry standards of marking things as being critical, error, warning, informational, debug, and trace, right? We want to have date timestamps, and of course these should always be UTC. We want to capture any exceptions. We want to capture elapsed times. We want to capture exactly where in the process the message came from, and then any data that goes with it. So for example, we could produce a datagram that could be rendered as a piece of JSON. Why JSON? Because it's a very compact way of storing complex data sets. And we can then have those stream from all of the steps in our process. We can have those looked up by activities in the real world, like scanning a barcode. And in fact, when we scan the barcode, it would generate on the digital side a message, and it would say barcode reader as its source. And it would have all the data that you see here. And we would know that the thing was scanned. And then we would say, well, based on that scan message ID, we're going to produce a series of qualitative values as someone inspects the contents of the box, right? They're going to enter, key in, all that stuff. In this case, by the way, we're using a Zipkin as a cryptographic trace ID, but there are lots of different kinds. What's important is they're globally unique. They're immutable. But one of the advantages to Zipkin, by the way, is you can validate that this ID hasn't been tampered with. And we want them to be pervasive. That means flowing from end to end in the system. So if we look at the journey of one journey from end to end, you can see that we go to the on-ramp and we inject the trace ID as soon as we can. And we have a place where it starts, we have processing, we have routing, we have more processing, we have a closing or ending process, and then we have an off-ramp where the journey ends. And through all those digital places, right, we're emitting not just one, but many logs, all correlated with the same trace ID. And if there are sub-IDs or record identifiers that go with that, then we want to include those as well. And what that allows us to do is to get a journey from end to end. And here you see just, a little dump of our journey store, kind of a fake example, but it's the sort of thing you can find out. And if there was an error or an aborted part of the process, we'd have a lot of metadata that goes with it. But the idea is that now we're in a position for a single journey from end to end to see its process and all the metadata that went with it. And that's very interesting. So what can we get out of that, right? We can get errors and error trends. And again, I'll repeat, the real value in synthetic transactions isn't necessarily an individual transaction, although there's a lot of value to be had there. It's about the trend of the same journey being repeated over and over again over time and seeing how that journey changes. So, for example, if you identify that a particular step in the journey takes too long to happen, and you ship a new version of that journey step to production, and we're continuously putting the same transaction that's going to exercise that step, we're going to have a very apples to apples way of saying the same transaction took this amount of time at this step before, it now takes this amount of time afterwards. And if we have a big enough data set, we can build a statistical model and we can do a student t-test and we can say, okay, yes, there is a significant difference between these two sets of data, and it's either better or worse. And if there isn't a significant difference, then the optimization that you tried to do didn't do you any good. So there's that. And then, errors and error trends, right? So systems have exceptions. We try to build them so they're compensatory. I'll do a video about Saga one of these days and talk about that. But the trend over time of the exception types and where they happen is really interesting when plotted out. It will give you information about how your system reacts under load or under special conditions, and sometimes as a function of the data that was fed to it. And those are interesting because if that's the case, they may be of interest to security as well. So, and that leads us to the topic of journey patterns, right? Frequent, aborted, and our favorite, anomalous journeys. Like, we don't expect to end up at this off-ramp from this on-ramp, but we ended up there. That's weird. So we should look into that. And that's often a sign of a routing problem, but it can also be a sign of a security problem. So there's lots of layers of useful stuff that come out of this. And then again, we talked about, measuring step time and making that part of the journey. And then just seeing if in between the steps, the time it took to go from one step to another is also yielded. And so if for whatever reason there's a really long time between this step and that step, it can mean that we have a really long queue length, or that step 2 was offline, or for whatever reason not processing. And those are really interesting insights as well. Like, we have strange, what we call dwell times between steps. And maybe it's related to time of day or day of week, because we're running the month end or whatever, and everything's just running slower, or what have you. And so you can get a lot of very interesting insights from synthetic transactions. And so my rubric is, if you are a sophisticated enterprise shop, this is part of your toolkit.